Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have m minus 1 square root divided by m minus 1 is equals to 1, and we solve this problem for all the values of m. So here we need to find all the roots of this equation. The very first thing we are going to do is here first we solve this problem for two methods. I hope so you like both of these two methods, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. And now we move toward the solution of this problem from first method. So here we move this m minus 1 from left hand side to the right hand side, and it will be written as m minus 1 square root is equals to m minus 1 times of m1 is equals to m minus 1. And further in the next step, here we need to remove the square root of m from left hand side, and for this we apply squaring on both of the sides. And when we apply squaring, it will be written as square root of m minus 1 whole square is equals to m minus 1 and its whole square. Here you see that these 2 and the square root are cancelled out by each other, and we will get here m minus 1 is equals to, in the right hand side we use the nice algebraic formula. So according to this, we expand this term as in this form: m square minus 2 times of m into 1 plus 1 square. And further, we move the terms from left hand side to the right hand side, so that we write it as m square minus 2 times of m plus this 1 square equals to 1, and here we move plus m to the right hand side, it will becomes minus m. This is minus 1. When we move it into the right hand side, it will become plus 1, and this whole equation is equals to 0. And now in the next step we have, this is m square minus 2m minus m becomes minus 3m, 1 plus 1 becomes 2, and this whole equation is equals to 0. So this equation will becomes quadratic in m variable, so that here we use the quadratic formula to solve this quadratic equation, or in other words we make the factors of this equation by using the factorization technique. So for this, here we move here we break the middle term. This is minus 3m, we write it as minus 2m minus m, and this is plus 2, and this whole equation is equals to 0. And now we will take common m from first two terms, and we get the remaining values are m minus 2, and from here we take common minus 1, and we get the remaining values are m minus 2, and this whole equation is equals to 0. And here we take common m minus 2, and when we take common m minus 2, we get the remaining values are m minus 1, and this whole equation is equals to 0. So now we divide this equation into the two cases. The first case is we write m minus 2 is equals to 0, and the second case is we write m minus 1 is equals to 0. And here we will take common, we move this minus 2 to the right hand side, and we get the first root of the given equation is m is equals to 2, and from here we move minus 1 to the right hand side, and we get the second root of the given equation is plus 1. So here we get, these are the two roots of the given equation which we get here from first method, and now we need to verify that is these roots be the solution, or is these roots be the extraneous root. So for verification of these roots, we need to copy down given question statement. Here it is m minus 1 square root divided by m minus 1 is equals to 1, and in this side we will be verify m is equals to 2, and in this side we will be verify m is equals to 1. So here first we verify m is equals to 2, so that we substitute m is equals to 2 into the left hand side of the above equation. So now after substituting this, it will be written as 2 minus 1 square root divided by 2 minus 1 is equals to 1, and when we put m is equals to 1 on here, it will becomes 1 minus 1 square root divided by 1 minus 1 is equals to 1. So here we need more simplifications, and it will be written as this is 2 minus 1 becomes 1 over 1 is equals to 1, and we obtain 1 equals to 1. So this shows that the value m is equals to 2 is satisfied our given question statement. And now here you see that this is 1 minus 1 becomes 0 over 0 form equals to 1. So this shows that our left hand side becomes indeterminate form, or in other words we say that it is undefined. So if this is undefined, this means that both of the sides are not equal, and if both of the sides are not equal, this concludes about that the value m is equals to 1 is not satisfied our given question statement. So we call that m is equals to 1 be the extraneous root of the given equation. So because m equals to 2 satisfied our given question statement, so this is the solution set of our question. So we have m is equals to 2 be the only one solution of the given equation, which we get here from first method. And now we can solve this problem for second method, and for second method we copy down the given question statement. Here it is m minus 1 square root divided by m minus 1 equals to 1. In the second method, we use the nice radical technique. You know about that. If we have any number x, we write this x as in the form of product of two radicals. So we have x is equals to square root of x multiplied by square root of x. So in the same pattern, this is m minus 1. We write it as m minus 1 is equals to square root of m minus 1 multiplied by square root of m minus 1. So here we replace m minus 1 is equals to product of these values, and it will be written as m minus 1 square root divided by m minus 1 square root multiplied by m minus 1 square root is equals to 1. So you see here this value and this value are gone, and here we will get m minus 1 square root only. We move this value to the right hand side and we get 1 equals to square root of m minus 1. And here we need to remove the radical sign from right hand side, and for this we apply squaring on both of the sides, and we get 1 square equals to 1. These 2 and square root are gone, and we get here m minus 1. This implies that we have moved this minus 1 to the left hand side, and it will be written as 1 plus 1 equals to m, and finally we get the value of m equals to 2. So in the first method we already verified that m is equals to 2 is satisfied our given question statement. So finally we have the solution set of this problem is m equals to 2. So this is our final answer of this question, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.